Hello everyone. Today we are here to discuss our seminar topic of our subject PTSP, probability theory and stochastic process. And today my topic is joint, conditional and total probability theorems. And let me introduce myself. I am Mohit Tainapuru from the class ECA with our roll number 411. And before going to the actual topic, or we are going to see what we are going to see in this seminar. We are going to see the basic definition of probability, what is probability, and the basic formula, general formula of a probability, what is random experiment, and the sample space, what is the sample space, and about event. We're going to see joint probability, conditional probability, and total probability with definition and their formulas. And we're going to relate the joint and conditional probabilities, and we will see the examples for each case, the joint, condition, total probabilities, and we are going to see the real life applications of these three probabilities. And next, before going to the actual topic, the basics that we want to know, the what is probability. The probability tells us how likely an event is to happen. So it mainly deals with the chance, so the percentage of chance, what we are likely to happen, the chance the event is going to happen. And we can also say that probability can be also defined as the number of favorable outcomes of an event A to the total number of equally likely outcomes. So if we toss a coin, so we want head. The number of favorable outcomes, if we toss a coin, the outcomes are heads or tails. So the favorable outcomes that we want is head, getting a head. Number of head is one. The total number of heads and tails, so two. The probability of getting a head is 1 by 2, that is 0.5. So what is next? What is a random experiment? Random experiment is a process or action that produces an outcome which can which cannot be predicted with certainty in advance, but all possible outcomes are not. So for this three random experiment, sample space, and even we're going to perform an experiment which is rolling a dice. So rolling a dice, it is a random experiment. And next, if what are the outcomes if we roll a dice? If we roll a dice, the outcomes are 1, 2, 3, 4, 5, and 6. Moving to next, the sample space of a random experiment is a set of all possible outcomes of that experiment. If we consider the above example, rolling a dice, the sample space can be termed as the all possible outcomes. So the for all possible outcomes for the above experiment 1, 2, 3, 4, 5, 6. So the number of outcomes are 6, and the sample space is 1, 2, 3, 4, 5, 6. And an event is a subset of the sample space associated with a random experiment. Even basically, it basically tells what we want to happen. So if we consider an event, so let us consider an event getting an even number. If what are the possibilities? 2, 4, 6 when we roll a dice. So the event is termed as what we want actually. So here, getting a even number when we roll a dice is an event. So moving to next slide, what is joint probability? The joint probability of a two events A and B denoted as P of A intersection B or P of A by B. P of A intersection B generally tells the common similar outcomes. So see, we can see here the pink color part is total outcomes that are possible for the event A, and the green color part is the total outcomes for the event B. So the middle part, which was shared by both the event A and the event B, is P of A intersection B. We go into that final probability that is a joint probability, and we are going to use this formula P of A intersection B equal to P of A plus P of B minus P of A union B. We are going to see an example. So consider tossing two coins simultaneously, both at a time. So what are the possibilities? The possibilities when we toss two coins are head. First coin is head and second coin is also head. First coin is head and second coin is showing tails, and first coin is tails, second coin is head. The fourth outcome is getting both the coins as tails. So here event A is getting an head in on the first coin. So what are the possibilities? for this event are the for this event are so a number of possibilities are here head and head comma tail. So there are two possibilities for this event. And next, the probability is two. So consider the probability is 2 by 4. See, the two outcomes are possible. So 2 by total number of outcomes is 2 by 4, 2 by 4, and it is going to be 0.5. Similarly, for this second one, the number of favorable outcomes are 2. And if we see the probability of it, P of number of favorable outcomes is 2 and total number of outcomes is 4. So the probability of chances of happening of event B is 0.5. So if we consider previous formula, P of A intersection B equal to P of A plus P of B minus P of A union B. What is P of A here? P of A is 0.5, P of B is 0.5, P of A union B. So number of outcomes common in both P of A comma B is P of A union B is 3. See what are they? Getting the first coin is 1. Getting head on the first coin is 1 and 2. Getting a head on second coin is 1, 2. So these three are common in both the cases. So P of A intersection A union B equal to 3. Total are 3. So number of uh, total number of outcomes are 3 by 4. 3 by 4. Total number of outcomes 3. Favorable outcomes 3 and total number of outcomes is 4. So it's going to be 3 by 4. That is going to be 0.75. If we subtract this 0.75 from this P of A, what is P of A? 0.5 plus 0. P of B 0.5 minus 0.75. That is P of A union B. So the answer will be 0.0.25. So 1 by 4. So if we consider the second one, so we're going to erase all this. Okay. Consider deck of cards. So what is a number of red cards in a deck of cards are 26, and getting an king when we pick up those red cards. So it was 2. So total what are total number of cards are 52. Total number of cards are 52 and getting a king of a red. So there are two kings in the whole red cards, and total number of outcomes are 52. Number of red kings are 2. So 1 by 2 by 52, that is going to be 1 by 26. So moving to the next slide. What is conditional probability? Conditional probability is a probability of an event occurring given that the other event has already occurred. So if we see this formula, P of B is already occurred, and we are going to find the probability after occurrence of B. So P of B is occurring. The probability of B is affecting the occurrence of the probability of occurrence of A. P of A by B. So the probability of occurrence of B. So P of A by B equal to P of A intersection B by P of B if P of B is greater than 0. Similarly, if we want the probability of occurrence of B, when P of A is already occurred, P of B by A is equal to P of A intersection B by P of A if P of A is greater than 0. Moving on to the next, we're going to see the example of for this conditional probability. Next slide. So example, rolling a dice. Event A is getting an even number when we roll a dice. What are the possibilities? 2, 4, 6. And the event B is pure number should be greater than 0. This was event B was already occurred before the occurrence of A. So what are the numbers greater than 3 are 4, 5, 6. And P of A intersection B. Even numbers in this 4, 5, 6 are 4 and commas 4 comma 6. P of A intersection B is 2 by 6 and P of B equal to 3 by 6. That is going to be 6 and 6 going to cancel and the final answer is 2 by 3. The relationship between joint and conditional probabilities. What joint probability? P of A intersection B equal to probability that the both event occurs simultaneously. The probability, conditional probability says P of A by B equal to P of A intersection B, P of B by B of B, when P of B is greater than 0. So if we multiply this P of B, we're going to take this P of B into this side, so LHS side. So P of A intersection B equal to P of A by B into P of B. Similarly, for the for the condition if A is already occurred, P of A intersection B equal to P of B by A into P of A. So main another theorem, total probability theorem. What total probability theorem actually says? That the law of total probability helps compute the probability of an event by breaking it into mutually exclusive cases. So in order to apply this total probability theorem, there are two conditions to be satisfied: mutually exclusive and they should be exhaustive. What mutually exclusive actually mean is the outcomes of A and the outcomes of B should not match. Means the intersection should be a null set. And what is exhaust to actually mean is the sum of the both outcomes should be equal to the sample space. Means so if we consider what is mutually exclusive, P of B1 intersection, P of B2 intersection, P of B3 and so on intersection Bn should be equal to null set. And P of B1 intersection, P of B2 intersection, P of B3 P of B1 union, P of B2 union and P of B3 union so on Bn union should be equal to the sample space S. So this is a formula that we are going to use for the total probability theorem. P of A equal to summation I equal to 1 to n P of A by Bi into P of Bi. This is a conditional probability statement. So next we are going to see an example. So consider, suppose you have three boxes. The box one contains two red balls and three blue balls. And the probability of picking up a ball from the box one is 0.4. And if we consider this box 2, there are one red ball and four blue balls in the box 2. Probability of picking up a ball from the box 2 is 0.3. And box 3 contains three red balls, two blue balls, and if we the probability of picking up a ball from box 3 is 0.3. You can choose a box at random and then draw a ball at random. What is the probability of drawing a red ball? So the probability of drawing a red ball, this is a conditional probability. Two, number of red balls in the box 1 by total number of balls. 2 by 5 equal to 0.4. And probability of picking up a red ball from a box 2 is 0. Number of red balls in the box 2 are 1 and total number of balls are 1 plus 4, that is equal to 5. 1 by 5 equal to 0.2. And probability of picking up a red ball from the box 3 is equal to number of red balls in the box 3, that is 3, by total number of balls in the box 3 is 5, that is equal to 3 by 5, that is equal to 0.6. So if we add this, if we substitute this in the equation, so if we for this example, I equal to 1 to n and I equal to 1 to 3, P of A by B1 into P of B1 plus P of A by B2 into P of B2 plus P of A by B3 plus P of B3. So if we consider that, substitute P of A by B1 0.4 into P of B1 0, that is 0.4, and plus P of A by B2, that is 0.2 into 0 P of B2, that is 0.2 0.3, and P of A by B3 into P of B3, 0.6 into 0.3. If we sum this all, we are going to get 0.4. That is the probability of getting a red ball for this, and this is a total probability theorem. And applications where we are going to use this probabilities are joint probability. We are going to use this joint probability in risk assessment, reliability analysis, conditional probability, uh, medical diagnosis and machine learning, total probability, communication systems and decision making. That's it. And thank you everyone for watching this.